Title and notes. Title of the notes today is solving trigonometric functions. Okay. Yeah. This will be on the test. Okay. So first of all, before we get into the solving, I'm going to give you a couple problems that lead towards the solving type problem. Okay. So I want you to, so example one, identify the possible quadrant or quadrants in which the terminating ray for theta could lie. Okay, and so for part A, we're going to look at the cos. I'm going to tell you that the cosecant of theta is greater than 0. Terminating. Okay, so identify the possible quadrant or quadrants in which the terminating ray for theta could lie. And so there's four quadrants. I'm not telling you what theta is, but I'm telling you that the cosecant of theta is greater than 0. And so in which quadrants could that happen? Right? And so you need to think about the unit circle. A couple things that come into play here. And you need to know that in the unit circle, the coordinates on that unit circle, the x and y coordinates, represent sine and cosine. Okay? And when you know that, then you can ask, well, in each quadrant, is x positive or y positive or negative? And based on that, you can get to an answer here. Okay? We also need to know that cosecant is the reciprocal of what? Okay, so the cosecant of theta is 1 divided by the sine of theta. And on the unit circle, the sine is the x value or the x coordinate or the y coordinate. So this is 1 over y. Okay, and we know that that's greater than 0, which tells us that y needs to be positive or negative. Which one? Okay, positive. So this boils down to the same question. Could be, in which quadrants is y positive? So in quadrant 1, everything's positive. Okay, and if y is positive, that means it's above the x-axis, so quadrant 2 would be the other one. And so our answer here would be quadrants 1 and 2. Because that's where y is positive, and if y is positive, that makes the cosecant positive. Okay. Okay, next. Same question. But now I'm going to tell you that the cotangent squared of theta is positive. Cotangent squared theta is positive, and we want to know where theta could be. Which quadrants can theta be in? Okay. So remember what the notation here means. This means you find the cotangent of theta first, and then you end up squaring it. And then after you square it, you get a positive answer. Okay? So could cotangent be positive? Could cotangent be negative? Yeah, because if you square a positive or if you square a negative, you're still going to get a positive answer. So in other words, in which quadrants is cotangent positive or negative? You get to, and those are the only options out there, right? And so it'd be all of them. Okay. Now, just for your sake, let's go through each quadrant and decide should cotangent be positive or negative in each quadrant. So in quadrant 1, is cotangent going to be positive or negative? Okay. Well, here's what we know. We know that cotangent of theta is the reciprocal of tangent, right? And we know that tangent is sine over cosine. So if we flip that fraction over, we know that cotangent is the cosine over sine. We also know that cosine is your x-coordinate and sine is the y-coordinate. And so in quadrant 1, both x and y are positive. And so we know that, okay, in quadrant 1, our cotangent is going to be positive. How about in quadrant 2? In quadrant 2, x is negative, but y is positive, right? And if you divide a negative by a positive, you get negative. And so cotangent's negative in quadrant 2. How about in quadrant 3? Both x and y are negative in quadrant 3. What's a negative divided by a negative? Positive. So the tangent and the cotangent are both positive in quadrant 3. And then we can say the same, think about quadrant 4, and you end up with negative. Because one's positive, one's negative. Okay? All right. So in this case, because we have the square, it could be all 4. So quadrants 1, 2, 3, and 4. Okay. So you're going to have to think about these quadrants when you're actually solving, because there may be more than one answer. And so now let's look at a problem where we're actually solving a trig function, solving for theta. So the instructions now are going to be, sorry, this should be example 2, not C. Okay, solve for all values of theta such that theta is between 0 and 360 degrees. And then give all answers in degrees. We'll work in degrees instead of radians, okay? And so I'm going to, let's say our equation is that the secant squared of theta minus 2 is equal to 0. And we want to know, okay, out of all the angles between 0 and 360, which ones can I plug into this equation to make this work? Okay, and there may be only one answer, there may be no answers, there may be 10 answers. We need to find all of them that work between 0 and 360. Okay. So the first step is to solve for secant theta. Okay? Solve for secant theta first. So we add 2 to both sides. And then we need to get rid of the square. So you take the square root of both sides. When you're solving and you take the square root of both sides, Well, when you take square root to the left side, it gets rid of the square. You get secant theta. But we're going to have to put, it could be positive or it could be negative root 2. Because when you square a positive or you square a negative, you're going to get what's positive, right? So when we're taking the square root, we're getting rid of that squared, but we need to remind ourselves, hey, either one would have worked. If I plugged in a positive or a negative, because I'm squaring it, I get a positive answer. Okay. So this is now where you think, well, what quadrant can secant be positive or negative in? What quadrants are we talking about here? 1 through 4. So each quadrant only gives you one answer. And so for every quadrant that you name, you get an answer. So we're saying there's 4 different answers here because this can happen in any quadrant. And so now we're going to find an answer in each quadrant. I'm going to change this to cosine. If you change it to either sine or cosine, that's really the building block of what we're working with, and it's easier to work with. And how do you go from secant to cosine? Reciprocal. What's the reciprocal of square root of 2? Well, it's over 1 right now. So when I flip it over, I get 1 over root 2 initially, but then I can multiply top and bottom by root 2, and I end up with plus or minus root 2 over 2. Okay? So then in quadrant 1, I'm going to draw that triangle, right triangle, hypotenuse of 1. Cosine is your x, so this is root 2 over 2. And you should recognize, hey, is this going to be what's our reference angle here that has that root 2 over 2 there? This is going to be 45 degrees. Okay? And so we just solved, we got an answer in quadrant 1. Theta is 45 degrees. Okay? So then we go to quadrant 2. That's where that's negative root 2 over 2. We know the reference angle is 45, but that's not the angle that we're really looking at right here, right? Because in quadrant 2, 45 degrees is not in quadrant 2. This is 90 degrees up here. This is 180 degrees over here. And so our angle's right in between them. So if I go back 45, I get 135. So that would be the solution from quadrant 2. Go ahead and find the solution in quadrant 3 and quadrant 4. Okay, so we should realize we're just putting 45 degrees in each quadrant, right? As a reference angle. So if I go 45 plus 180, I get 225. So that's my answer from quadrant 3. And then put another 45-degree reference angle in quadrant 4. And so if I go back 45 from 360, what do I get? 315. And so those are my 4 answers. Okay. And so that's what it's like to solve these equations. You have to first get it in terms of sine or cosine or tangent. Okay, something we're more familiar with working with. And we're really after what reference angle is it talking about. It's either going to be 30, 60, or 45. In this case, it was 45. And then I just put that reference angle in each of the quadrants that we were interested in. And here is all 4 quadrants. And then I got those answers. Okay, so let's try another example. This time we're going to do it in radians. Example 3. Solve for all values of theta. Such that theta is between 0 and 2 pi. radians. And then give all answers in radians. And the equation I'm going to give you is this. The cotangent of theta plus root 3 times the cosecant of theta minus 2 equals 0. So this, we got to find the angle that we can plug in to both of these so that when we multiply it together, we get 0. Okay. Now, if you remember back to solving quadratics, okay, we solved by factoring. And if we had something like this, x plus 2 times x plus 1 is already factored and equal to 0. Do you remember how we solved for x? There's something called the zero product property where we were able to take each factor and separate them and set them equal to 0 individually and make the problem easier on us. And we'd end up with -2 and -1, right? That's what's set up for us here. We have two factors that are set equal to 0, and so we can separate them into two easier problems to work with. So one is that the cotangent of theta plus root 3 is 0, and the other one is that the cosecant of theta minus 2 is 0. And you solve them individually. So the first one is going to give us some answers. Maybe 2 answers, maybe 4 answers. We'll find out. And then the second one we're going to solve and we're going to get answers. And then we combine all those answers together for our final answer. Okay, so it's like 2 problems in one. I'll do the first one with you, and I want you to do the second one on your own. So the first one says the cotangent of theta plus root 3 is 0. So I want to get cotangent by itself. So subtract root 3. And then I'm going to get this in terms of tangent. We can leave it in cotangent, but I'm just going to get this in terms of tangent, which is the reciprocal, still negative. And I'm going to multiply top and bottom by root 3. And then, oops, it should be root 3 over 3. And what I'm really after here, guys, is what reference angle am I working with? Is this this 30, 60, or 45? And some of you already know, okay, the root 3 over 3 goes with 60. Or some of us are still learning. And if you're still learning, this is what you do. You get a triangle. So I'm going to try 60 since you guys said 60. So let's make our reference angle 60, which would make the sine over here root 3 over 2, and would make the cosine 1/2, right? And then try it. Sine over cosine would be root 3 over 2 divided by 1/2. And when you reduce that, you get root 3. You don't get root 3 over 3. And so it's not 60. Right? It's not 60. So try something else. Try 30. If we have 30, we got 1/2. And we got root 3 over 3 here. Sorry, root 3 over 2 here. And so when we do that fraction, we get 1/2 sine over cosine, which is 1/2 times you can multiply by the reciprocal. You get 1 over root 3. Multiply top and bottom, and you end up with root 3 over 3. So now we know, hey, our reference angle is actually 30 degrees, not 60 degrees. Okay. Now, because the tangent is negative, what quadrants are we talking about here? Remember, if we go back a couple problems here, we were talking about cotangent which was x over y, but tangent's the same thing. And we saw that the cotangent was negative in quadrants 2 and 4. For the same reason, tangent's going to be negative in quadrants 2 and 4. So that's where my answer lies, in quadrant 2 and 4. So you have to identify your reference angle. You have to identify what quadrant to put it in. So we want to put it in quadrant 2 and 4 because we have a negative tangent. And so then once you're there, it's pretty easy. You just put that reference angle in quadrant 2 and 4. So here's 30 degrees in quadrant 2. If this is 180, what would this one be? $150. Okay, but I'm in degrees. We need to be in radians, right? So no problem. Let's switch over to radians. So here's 0 radians. This is pi radians. And 30 degrees is how many radians? Pi over 6. So I'm going to change this to 6 pi over 6. And if I go back, this is going to be 5 pi over 6. Okay? And then I put 30 degrees in this quadrant. And so this is going to be 12 pi over 6. Go back, and we get 11 pi over 6 here. All right, so my two answers for theta from this problem are 5 pi over 6 and 11 pi over 6. Okay?
All right, now don't forget we have a second half to work on. Which is the cosecant of theta minus 2 equals 0. So solving for cosecant theta, we add 2 to both sides, and we can change this to sine theta by getting the reciprocal of the cosecant. So sine theta is 1/2. We want to ask ourselves two questions here. What quadrant are we thinking about? And what is our reference angle? And so if we think, I'm going to go reference angle first. We're working with triangle. It's going to be 30, 60, or 45. If we try 30 out, we know that when the hypotenuse is 1, the side length across from 30 is 1/2, which is, in this case, the sine. And so 30 degrees is our reference angle. And that is pi over 6 as in radians, because pi is 180, and 180 divided by 6 is 30. And sine is positive in quadrants 1 and 2, because sine is your y value, right? On the unit circle, if you have a coordinate xy, your y value is sine. It represents, it's positive in those two quadrants because it's above the x-axis. So to get my answer, I put a reference angle of 30 degrees in both quadrants 1 and 2. And I'm looking for those angles in radians. Well, here's 0 radians, and I'm going to the right pi over 6, so 30 degrees we know is pi over 6 radians. Now if I go full half circle, that's 6 pi over 6 radians, and I'm going to go backwards 1 pi over 6, so that puts me at 5 pi over 6 radians, and that's our other answer. So we get theta is 5 pi over 6 and pi over 6. Now that's the second half of this problem. Now we need to combine that with the answer we got from the first half. So putting those two answers together, our final answer is theta is going to be pi over 6, 5 pi over 6, which is both answers have that, but we only need to write that once, and lastly 11 pi over 6.